Right, still talking about measures of spread. The most useful measure of spread we're going to use this semester is called the standard deviation. It's a good way to measure how spread out a set of data is. It's not terribly intuitive, but it is mathematically not very difficult, and we're not going to have to do it for ugly situations. So I got a population here, very simple, 10, 15, 20, 25, and 30. We're going to calculate the standard deviation, which is a number that will tell us how spread out things are, and we'll talk about exactly what it means in the future, not this time. We'll talk about how to calculate it here. First thing we're going to do to calculate the mean, and you want to do this along with me, okay, is find the average for this set of numbers. We want to find the mean. And the mean here, we're going to call x with a bar over it. And I'm going to start building a formula down here. We'll talk about what it means as we go. X bar is the symbol for the mean of a population. So our X bar here, it's pretty obvious that's going to be 20, right? We add these together, we're going to get 100. Divide by 5, we will get 20. And then we're going to subtract X bar from each of the members of this set, from each of the members of the population. That's going to be our deviation. How far away from the mean is this number? That's where deviation comes from. This one, 10 minus 20, is going to be negative 10. Right? So I'm starting with the number, each number, right? Each number is x, and from each number we're going to subtract the mean. So 10 minus 20 is negative 10, 15 minus 20 is negative 5, 20 minus 20 is 0, positive 5, and positive 10. All right, that's the deviation for each of these numbers. This is 10 units below the mean, 5 units below, right at the mean, 5 above, and 10 above. Now what we're going to do is we're going to standardize those. That's how we get the standard deviation. And the way we're going to do that is to square them, and then average them, and then square root the result. Okay, so square each of these numbers first. Each of these x minus x bar, we're going to square that. Negative 10 squared is 100, 5 squared is 25, 0, 25, and 100. Okay, so we're squaring them. And then we're going to average them all together. If we add, well, before we talk about that, notice that even if the number was below the mean and we ended up with a negative deviation, when we square that, it's going to be positive. So you should have no negative numbers here, which means you actually really don't care if these numbers are negative. Just think, how far away from the mean is it? You could have left that as positive 5 and positive 10. It wouldn't have made any difference. We square them all. We want to add them together. We want to average them together. So we're going to add them up and then divide by how many there are. Remember from last time, or sometime, average, or to add them up, we put a sigma in front. And then to divide by how many there are, we put an n under there. We divide by n. So here we're going to add them up. 100 plus 100 is 250. So we get 250 divided by 5, which is 50. And then the last thing we're going to do is we're going to square root them. We're going to square root this mess here. And that's going to give us 7.07, which I totally did in my head. I did it in the calculator before we started here. I wrote it down so I wouldn't forget. So that tells me the standard deviation for this set of numbers, which we call sigma, lowercase sigma. And that looks like a little head with a swoopy hair thing on it. I don't draw the thing too swoopy when I draw sigma. Typically I draw kind of straight like that. But that is a lowercase sigma, so the lowercase version of this guy here, and that stands for the standard deviation of the population. Talk about standard deviation of a sample. We use a different symbol. We'll talk about that later in the semester. I'm going to ask you to do this for a set of 5 numbers that work out relatively nicely. Let's do this one more time. I'm just going to throw up a few numbers here. 2, 12, 15, 17, and let's see, if I make this 17 and 15 is 32, 44, 45, 46. Let me put a 14 in there. It's much easier if the mean comes out to be a whole number. So first thing we do, right, let's follow the formula this time. First thing we do is we find the mean, and that's going to be 12, 13, 14, 28, 38, 43, 53, 60 divided by 5 is 12. So that's going to be 12. If we subtract 12 from each of these, we're going to get 10, 0, 2, 3, and 5. Right? 2 minus 12 is negative 10. We don't need to worry about the negative. Okay, so take each of those and subtract the mean from it, and then square the results. 100, 4, 9, and 25. Add them together, divide by how many there are, and then square root the result. So we add these together, we get 125, 135, 138. Divide by how many numbers there were to begin with, which is 5, and then square root. I did not do that one ahead because these are just fake made up numbers. So let's do 138 divided by 5, and then to the 0.5 power for the square root. That gives us 5.25. Now, of course, that's a decimal approximation. It's not exact. So there's our standard deviation, which tells us what? Not a heck of a lot, right? But if you look at the numbers we had up before, if you want to rewind, the numbers were farther apart. Here, there's only 15 between the biggest and the smallest, and these numbers are sort of concentrated together. And our standard deviation came out to be smaller than it did for the other set. The other set was more spread out. The standard deviation should be bigger because standard deviation is a measure of how spread out things are. And this came out smaller, which is consistent. We are not done talking about what standard deviation means, but you may want to watch this a few times to review how to compute it, because I am going to ask you to do this for a small set of 5 numbers with a nice X bar later.